So I already introduced myself, the president of the Dynamic Spectrum Alliance, and it's a global cross-industry non-for-profit organization. We represent different high-tech companies, and about half of our membership are universities and non-for-profits, and we promote efficient use of the spectrum. In general, right now, one of our main subjects is Wi-Fi, and we are very active, like trying to spread the message about the importance of Wi-Fi and the importance of having enough capacity for Wi-Fi 6E and Wi-Fi 7 in terms of a spectrum. So let me start by an statement that I think it's clear for everyone. Wi-Fi is essential to broadband. Now in 2022, according to Cisco VNI projections, at least more than half of every internet connection starts or ends by a Wi-Fi connection. It could be through exclusively Wi-Fi networks. It could be also through smartphones and mobile devices or TVs or any type of device that has a Wi-Fi chipset. So that's really important. So Wi-Fi is essential to broadband, and the 6 gigahertz band is essential to Wi-Fi. So we have published a paper that explains why that band is so crucial for 6 gigahertz for Wi-Fi. Let's see some numbers coming from the Wi-Fi Alliance. As you know, these are by 2022, and currently there are more than 18 billions of devices in use. And to give you some figure, about more than 10 billions of mobile subscriptions globally. So that's a lot of devices. And I think we can see it clearly because it's not only mobile phones, tablets, but it's also computers. And now more and more devices are connected. Like, for example, TVs and every connected house device usually is connected to Wi-Fi. So that's a number that is relevant, and it's currently growing. In terms of the standardization, the Wi-Fi industry had been having there is a standardization by IEEE. And currently, when we talk about the latest standard, it is Wi-Fi 6. The Wi-Fi Alliance has been putting in place all the certification procedures. So they started Wi-Fi 6 in 2019 and Wi-Fi 6E in January 2021. So let's explain. Wi-Fi 6E means Wi-Fi 6 in the 6 gigahertz band. So that is the main concept. So far, there have been more than 400 Wi-Fi 6E certifications. That's really is not something in the future. It's a reality right now. And we are also seeing a lot of procedures to make sure that we could have all the types of use cases for Wi-Fi 6E. So it means very low power devices, low power indoor devices, and in countries like US and Canada, standard power devices that can operate outdoors. There is also ongoing work for Wi-Fi 7. So that will be known as IEEE .11be. And it's targeted to be to have the first advances of the standard by 2023 in May, and to be commonly available by 2024. So that's the ongoing process. Indeed, we have heard some announcements from providers that say that now they already have Wi-Fi 7 chipsets. I recently was at FTTH event in Vienna, and ZTE was announcing that they had this component, including Wi-Fi 7. So that's currently ongoing. In terms of Wi-Fi 6 and Wi-Fi 6E chipsets, it has been also a tremendous success. I took this from one of our DSI members, Broadcom. They have announced in March that they shipped 1 billion Wi-Fi 6 and Wi-Fi 6E chips. So that's huge, and that's growing very fast. So there is, as they explain, consumers and enterprises are actively requesting that type of devices and that new technology. And then if we see in terms of products, we have also seen, this is taken from Intel as a courtesy, there are so many devices now that are integrating Wi-Fi 6E. So we have more than 20 routers and access points, more than 14 smartphones, because this is December 2021. So now there are more. Laptops are already integrating Wi-Fi 6E, desktops, PCs, and also, as I mentioned, smart TVs. So that's what we have in terms of devices and adoption. But something that is very important to mention is that Wi-Fi 6E is not available in many countries because regulators and spectrum authorities need to open and license access or license exempt access to the 6 gigahertz band. So if they don't open the band, they cannot benefit from Wi-Fi 6E, and they won't benefit from Wi-Fi 7 in the future. So let's see here, we have the map that shows how we are in terms of adoption. So currently, let's start by the Americas. We have 8 administrations that decided to open the entire 6 gigahertz band, so 1200 megahertz of additional spectrum in the 6 gigahertz band. Those countries are Canada, US, Brazil, Chile, Peru, Honduras, Guatemala, Costa Rica. And we recently had also many consultations from countries like Mexico, Colombia, Argentina, and Dominican Republic. So we see in terms of harmonization that the Americas has more than 70% of the market has decided to open the entire 6 gigahertz band. That's very positive because then we have economies of scale and lower cost for customers. Then if we go to region 3, we can see that the first adoption for the entire band was South Korea. And then they have been followed by some other administrations that open a portion of the band. And those are Australia, Hong Kong, Japan, Malaysia. And some of them are considering to open the entire band so they can benefit from more channels, more capacity, and better performance. In the case of region 1, so Europe, Africa, and Middle East, what we have seen is a recent decision from the European Commission, from the European Union, opening the lower part of the 6 gigahertz band. Now there are ongoing studies about the future of the upper 6 gigahertz band. So one option is to identify that, and the other option is to use that band for license exempt access. So there are studies for both. One for IMT identification, that's part of the World Radio Communications Conference studies. And for Wi-Fi or in general license exempt access, there is a particular group handled by SE45. That's a group within ECC and CEPT. So that's going on in Europe. In Africa, there is a recommendation from African Telecommunications Union to open the lower part of the band for license exempt access. And some countries are studying also the entire band. And we had the Kingdom of Saudi Arabia in Middle East. That was the first adopter. They opened the entire band. So now they're really one of the most advanced countries in terms of having access to this latest technology. And they have been recognized also as 5G leaders. So you can see Korea, Saudi Arabia, US, Canada, mainly all the 5G leaders combine the best of 5G networks with the best of Wi-Fi networks, giving a spectrum for both and making sure that the two technologies can complement each other. Let me focus a little bit on the European case, because that's part of the purpose of this event. So in the case of Europe, there is an important reality is that indoor connectivity carries the vast majority of internet traffic. So 90% of data usage is indoors. That's according to BEREC. And 90% of time is spent indoors when we are connecting to the internet. So it means that we need to make sure that there is not a bottleneck for indoors connectivity in Europe. That indoors connectivity is most of the time provided by Wi-Fi, and it's a combination with other technologies. So we could have fiber for backhaul, satellite, for example, in rural and remote areas, 5G that could be providing, for example, fixed wireless access, and also when we are using it outdoors, like glasses or any body area networks, those devices are unlicensed and combined with 5G. So there is a complete ecosystem that needs to have additional licenses and access. And in Europe, we have noticed that sometimes people give Wi-Fi for granted. We are so used to see it. It's omnipresent. We use it all the time. So it's important to give the message that we shouldn't give it for granted. We need to make sure that those Wi-Fi networks that we have today will go to provide the gigabit capacity that is targeted by the 2030 program of the digital decade path. So there are two important goals in the path to the digital decade. One is that all households will be covered by a gigabit network, and with all populated areas covered by 5G. That's very important, and we completely support it. And then there is another one that says that all European households will be covered by a gigabit network. If we want to have gigabit networks for every household, it's not just about deploying fiber to the home or very performant 5G networks outdoors. We need to make sure that there is an indoors connection that will provide those throughputs that are needed. So in that case, that's why we need to take into account Wi-Fi 6E and Wi-Fi 7 by 2030. We think that it's important to keep that neutral approach because in reality, that's how it works. We combine different technologies, and we are going to see in a moment how the traffic is distributed. I mentioned a little bit about all the applications, but the transition to Wi-Fi 6E and Wi-Fi 7 is really based on needs from users and so many use cases that we are seeing. Many of the new applications won't be operating and won't be adopted with the current technology. We need to make the transition to Wi-Fi 6E and Wi-Fi 7. So it's not about providing the same services we are having now. It's about transition for new applications. Many of them like IoT, real low latency applications for smart warehouses, smart cities, augmented virtual reality. So all those applications will need those new technologies and that additional spectrum. One important aspect in Europe is the green transition. That's one of the main priorities for Europe. And we are convinced that for indoor connectivity, the greenest solution is a combination of fiber and Wi-Fi. Because if we try to provide indoors connectivity with wireless, for example, mobile networks that are outside, then we'll have to increase the power of outdoors base stations so they can cross the walls, and that is not power efficient. So we think that there is a perfect complement, as I mentioned before, having 5G for outdoor coverage for many indoor applications that would be able to have their private networks or their vertical applications. But for many of the households, the best combination is fiber and Wi-Fi. And for rural areas and farmers and agriculture, maybe the best combination could be 5G and Wi-Fi or satellite and Wi-Fi, depending on the context. We have been working with different European stakeholders, and we have sent a letter to members of the European Parliament, ambassadors, and commissioners. And that was signed not only by DSA, we are just part of it, but also by many European groups. Like, for example, there is Allied for Startups, because for startups, they really rely on Wi-Fi for connectivity. Also, digital SMEs, small and medium enterprises rely on that Wi-Fi connectivity. Europe XR, so that is the association that is working on augmented and virtual reality and mixed reality, and there is a huge deployment in Europe in terms of content and new applications. So all those stakeholders need that complement, as I was explaining before, and need that additional capacity of Wi-Fi 6E and Wi-Fi 7. We have been also working at the Digital Decade, and I would like to highlight here, we recently had an event this month, and we were very glad to hear statements from a member of the European Parliament, Josiane Cutajar, and she said that Wi-Fi can play an important role in reaching the goal of ensuring that we have the full coverage of all European households and business premises regarding of their location by next generation networks. And she mainly highlighted the importance of Wi-Fi for indoor connectivity. I would also like to cover today, to refer briefly to two new white papers that DSA has published. One is about how do Europeans connect to the internet, and the other one is about the socioeconomic benefits of IMT and airlines versus airlines in the upper part of the 6 gigahertz band. So the first one, it's about how do Europeans connect to the internet. So we have reviewed this is public information published by the Benetza in Germany, the regulator, and Ofcom in the UK. So we took into account that information, and we were considering how is the traffic of really happening in Germany. So this is the example of Germany. You can see in blue the fixed traffic, and in red the mobile traffic. Both are growing. Both are very, very important. But when you see the amount of traffic, most of it is going through fixed networks. And then in the second graph, you can see it as a percentage of total traffic. And it's very clear that, again, fixed traffic is really taking a good part of the networks. So that shows that the vast majority of traffic occurs over the fixed network. We say like, okay, that could be just the case of Germany. So we had this exactly the same behavior, very, very similar from the information in the UK. And that is also the same type of results that we have obtained in our own study done by a company named Asia in Europe and the US. North America, US, Canada, that was a while ago, but that was also taken from real traffic measurements. So we assume that from all those sources that are showing the same behavior, that's really the case. This is the case of the study we had with Asia that shows the amount of traffic that we can have per day. So in North America, it could be between 8 to 10 gigabytes per day. And you can see how it's going through the current frequency bands for Wi-Fi, 2.4 and 5. And we can see in Europe a similar behavior, but less traffic, between, let's say, 4 and 10 gigabytes per day. So even if we take those forecasts, what we are seeing is Wi-Fi traffic is doubling every 3 years. And that's one of the main justifications of why we need additional spectrum for Wi-Fi. And the capacity we have in the 6 gigahertz band is for 7 channels of 160 megahertz of bandwidth. And for Wi-Fi 7, we might have 3 channels, non-overlapping, of 320 megahertz of bandwidth. So that's really a future-proof decision because that will provide the future spectrum requirements for Wi-Fi 7. So in this study that I just mentioned about how do Europeans connect to the internet, one of our conclusions is that if we are going to see the amount of traffic, it's really much more efficient to dedicate that upper part of the band of the 6 gigahertz band for Wi-Fi. And that's the only band that is currently targeted by Wi-Fi industry. So it's really important to enable that. There are some recommendations and conclusions. I won't go through that. And then we also had another socioeconomic study where we were comparing what should Europe do for the upper part of the band. We took into account 3 scenarios. The first one is like, okay, let's use that frequency band for licensed nationwide IMT. So basically typical mobile networks. Then another argument we are hearing from industry is, okay, we need that band for local licensed IMT, so mainly verticals and private nets. And then we say, like, okay, what happens if we use that band for license exempt? I really encourage you to review the entire study. It was done by LS Telcom in combination with VBA, a company that had the responsibility for the economic study. LS Telcom was doing the technical study. And we found that the third scenario provides the most suitable results in terms of an investment cost perspective, because it is really expensive to use the 6 gigahertz band to provide coverage, like metropolitan coverage, especially if we compare that to all frequency bands that are already available for mobile networks and indeed have a lot of ecosystem, like, for example, the 3.5 gigahertz band, and even in In Europe, we have 2.3 and 2.6. So there are other frequency bands that could provide better coverage and good capacity. Also, from the cost perspective, for the capacity and private network in Europe, now it's possible to use the 3.8 to 4.2 gigahertz band. So that's from the investment cost perspective, that is more optimal. Also, it's better to use that band in terms of cost versus quality of service deployed. So again, we found that Wi-Fi or airlines in general will provide more value in general for these type of applications. And again, because they combine with other technologies. So that is the case of Europe. Let me briefly refer to the case of countries that don't have the same fiber penetration. Well, I would say Europe and Middle East. Middle East also in some countries have a great fiber penetration. And then that's when they find most of the value for indoors connections. But also the decision about additional capacity for Wi-Fi 6E and Wi-Fi 7 will benefit economies in developing countries. So let me take here the example of Indonesia. We made a study about social and economic benefits from designating the entire 6 gigahertz band to unlicensed use. And basically what we did is we took different sources of value. Like, for example, let's say one of the sources of value is deployment of free Wi-Fi hotspots. Because for many citizens, they cannot afford a fixed internet connection at home. Their mobile connection is not the latest, so they don't really have the broadband experience. So they really rely on Wi-Fi hotspots to access internet. And we found in the case of Indonesia is one of the most important sources of value. So we took different sources of value and calculated their impact on GDP, on producer surplus and consumer surplus. And there are models. All this is open information, so you can review the model, you can review all the assumptions we're doing, taking public information. So that's how we calculate that economic contribution. Other sources of value, for example, are increased broadband speed by reducing Wi-Fi congestion, enhanced coverage and improved affordability, or even deployment of augmented virtual reality solutions. Because for countries that are not having still that broadband capabilities, Wi-Fi 6E and Wi-Fi 7 can provide throughputs of the range of gigabits per second. So they could have those AR/VR networks faster, and they can deploy, Indonesian companies can deploy their own content that could be used for education, for training, for enterprises, and then they will have a fastest adoption, and that will contribute to the growth. We also studied how it is the effect, because it's not like you will get that economic benefit since the beginning. It's in a period of 10 years, and it has this behavior because it takes a while to start the adoption and start the penetration of new devices, etc. But at the end, what we found is like the cumulative effect is $188.78 billion for the Indonesian economy. So that is really important. It's not negligible. You cannot neglect that influence. And all that by creating an open ecosystem with license-exempt access where many stakeholders can benefit of those new technologies. One important highlight here is that there is an opportunity cost. So if spectrum regulators and authorities delay the decision, then they are losing, all this will switch in time. So they are losing the opportunity to get those economic benefits. So that's, it's not only about the action that should be taken for spectrum, is when you take that decision. And it also has a huge impact on closing the digital divide. We calculated that the allocation of the entire band will contribute to close the digital gap because then those that are providing internet services through Wi-Fi equipment, they will be able to provide more service and to have more affordable access. So we have estimated that more than 1 million Indonesians will be able to gain access to the internet thanks exclusively to this decision. Of course, there are many other decisions that will create a chain effect. And also we calculated that there will be an impact on households. We have done similar studies. I just took Indonesia as an example, but we have done similar studies for other developing countries like Kenya, Peru, Colombia, South Africa, Nigeria, Mexico, and Brazil. And we have found that in general, we have a similar behaviors. It means that the impact is really related to the GDP of the country. And in some cases, it's more like, let me compare Colombia and South Africa. Both have similar GDPs, but in South Africa, the wireless internet service providers are much more organized and they're really closing that gap in terms of internet access. So in the case of South Africa, that will have a higher impact than we could have, for example, in the case of Colombia. And we have also calculated the contribution to closing the digital divide in, for example, Kenya and South Africa. So in those countries, we also have those effects. It could be more or less. If you see Kenya, it's more than 1,400,000 people. And if you remember, it's similar to the case of Indonesia, but just because of the local conditions in Kenya, it will have a higher effect on closing that digital divide. So in conclusion here, I would like to mention that there is a gigabit imperative. New current uses and future use cases are driving demand. So it means that it's needed to have additional spectrum in terms of band in general, but also in terms of bandwidth per every channel to attend that wireless demand and to provide the wireless capacity that users are requesting. That has been clearly showed with the COVID-19 situation. And even now after COVID, I think that the way of life has changed. And now we are really like focused on really providing that connectivity that is needed. The Wi-Fi technology standards and interoperability are all in place today. They're ready for regulatory action. And in those markets that made the decision about regulations, we are seeing a great growth and how industry is delivering. Important aspect to mention, the 6 gigahertz band is already used by fixed services. So there are many backhaul links operating in that band and also fixed satellite services. However, they can perfectly coexist with Wi-Fi. So there are rules in places. For example, in the US, there are more than 100,000 fixed links. And the decision of the FCC after they took into account so many studies is that it is possible to coexist with those fixed links if we have the right rules in place. So for VLP, very low power and low power indoor conditions, just by the power levels. And for standard power outdoor applications, we need a system that is named AFC, Automated Frequency Coordination. If we have license exempt technologies, if they can operate to the full 6 gigahertz band, that's the best way to support future growth and innovation. And even for 5G, it's possible to use license exempt spectrum for 5G new radio unlicensed that has been completely recognized by 3GPP a while ago. It's already available there, and that's an option also for companies that would like to use that spectrum without paying any fees for spectrum access. 500 megahertz is not enough. So that's what we are working with administrations like Europe to show that that decision is a good first step, but it's not going to be enough. And there are many social and economic benefits that flow from designating entire band for license exempt access. And there is also a large opportunity cost of inaction. So thank you so much for your attention. If you would like to hear more about current activities of the Dynamic Spectrum Alliance, I invite you to our global summit that will be in September in Paris, France. So thank you so much, and we'll be happy to answer any questions.
Martha, that was great. Really, really interesting. So we have Anders has asked about the importance of Anders has asked about the importance of open roaming for seamless roaming between Wi-Fi and LTE/5G.
Well, I have seen that's not something DSA is doing or working on. We're more on the spectrum side, but I know that organizations like the Wireless Broadband Alliance Indeed, Tiago is their CEO and he's based in Portugal. They have been actively working on open roaming for Wi-Fi networks. So that means that if you have your mobile, you just register once and then you will be able to connect in a seamless way to different networks. That's all I could say about open roaming. I would really encourage you to see more on the, they have been having very nice tests. I think they had one in Barcelona, the Mobile World Congress. And I think they're also having in one city, like those deployments of open roaming networks. But that's all I could say. I'm not personally working on that.
Okay, he also commented that he feels the EU is way too focused on 5G and totally missing the importance of Wi-Fi 6E and the urgent need of opening up more spectrum for it in the EU. So I think possibly we all agree with that.
Yes.
Sorry, go ahead.
Yeah, about that. Indeed, I have been in so many meetings with members of the European Parliament and it's like, oh, but Wi-Fi is there. It's like, yeah, I mean, it's there, it's working. So again, as I said during my presentation, many stakeholders give Wi-Fi for granted. So when we think about 5G, we need to take actions. It's really going to change the way that we connect to the internet and the way we interact. That's extremely important. But we cannot affect other technologies in that effort to make sure that we have 5G and fiber. So at the Digital Decade program, one of our key messages has been you should be neutral, like try to promote 5G, try to promote fiber, but please also mention other technologies, because then when policymakers in every country are going to make the decisions, they're going to take into account satellite, Wi-Fi, fixed wireless access, that we need that combination. So I completely agree. We are working on that, and hopefully we will see a more, sometimes people say balanced approach, and they mean that splitting the band, half for IMT, half for Wi-Fi. But that's not the way we think it should be seen. It should be seen from a holistic perspective. There are so many other frequency bands that have been identified for IMT, where we could have 5G, and we could make sure that capacity and coverage are provided. But in the case of Wi-Fi, the only frequency band that we are targeting right now and that's going to provide that capacity and coverage is the 6 gigahertz band. So let's see what happens. I think it's a very interesting subject.